In this lab, we will be observing oscillating motion and the energy associated with the system described. To start off, these are the physics concepts that are used in this lab. We have Newton's second law with the position and velocity update formulas calculated using the spring force and gravitational force. We introduce the energy principle monitored through all the energies present in the system, which are namely kinetic, gravitational, and spring energies. We use the Earth and the spring mass as a system together. The change in total energy has to equal zero, as that is the work done and is equal to the sum of the changes of these individual energies. To observe the experimental data, we're using Tracker. Using Tracker, I tracked the position of the spring mass frame by frame and got the following position and time graphs for the x and y axis. As you can see, this is oscillating motion. The constants have stayed the same from the pre-lecture videos, and they are mentioned here as the mass, spring constant, and the relaxed length of the spring. For the computational model, the net force is given by the sum of the spring force and the gravitational force. Then Newton's second law is used to update the velocity and subsequently the position of the spring mass. To find the change in energies, the initial energy values for kinetic, gravitational, spring, and total energy is calculated. In the calculation loop, the initial value is subtracted from the current energy value to monitor its change. Here are the position time graphs with the model in blue and the experimental data in red. There is a slight difference in the values, and this is because there are manual errors in the position tracking in Tracker, and secondly, the model does not account for the drag force of air resistance. Now to answer the what-if questions. In the energy plot graph below, you can see that the energy principle is satisfied. The energy principle states that the change in energy is equal to the work done. With our system including the Earth and the spring mass, there is no work done. Thus the change in total energy should be zero, as shown by the orange line in the graph. Now for the difference in the period of oscillation. These are the periods of oscillations as calculated in the x and y axis. In the x-axis, it's 1.646 seconds. From the y-axis, it's 1.519 seconds. This looks like a small difference, but can create large changes in the spring constant and relaxed length of the spring calculations. The y-axis estimate should be used because there is more motion in that direction, causing a lower percentage error. This is the end of Lab 4.